Welcome to July 12th LeetCode Challenge, Isomorphic Strings. Given two strings, S and T, determine if they're isomorphic. Two strings, S and T, are isomorphic if the character in S can be replaced to get T. All occurrences of a character must be replaced by another character while preserving the order of the characters. No two characters may map to the same character, but the characters may map to itself. So if you guys aren't familiar in, I guess, math, isomorphic meaning that a character, so for instance, if you have a string in S, it could be mapped one-to-one with a character in T. So that means that you need two conditions to occur for that to happen. It means that the character in S cannot be represented by anything else other than one character in T. And that means that no two characters share the same mapping of the same character. And then we want to also preserve the order of the mapping as well. Meaning that, for instance, if we have the example egg here, EGG to add, that means we map E to A, and then G to D, we preserve the one-to-one isomorphism, and also we preserve the order of the mapping as well. Unlike this, if we have O here twice, but they're not mapping towards A or R appropriately, so return false. And we have paper here. You see how we have P mapping to T, since A mapped to I, E on the left side paper mapping to L, and then R mapping to E. So let's go through some our constraints here. So a string is between 1 to 10 to 5 to the 4th, 10 to the 4th. That's great. So it's telling us that the length of T is the same as length of S, so we don't have to check for that. And S and T consist of any valid ASCII character. So it doesn't have to be just letters. It could be any symbols as well. So let's kind of follow the example given here. So we're going to use a mapping, so a character mapping with a dictionary. It's my first intuition on that, and it's pretty straightforward. So you basically, in order to kind of fulfill that algorithm, you need to basically determine two conditions. The first thing is, if you haven't seen a character before, for instance, you go to paper, right? And with title, the first thing you iterate through paper, you first find P. You don't have P yet, so you need to make an assignment. So you need to map P to T. So that's the first scenario. That the first case is that there's no mapping that exists in either dictionaries. And then you go through A, then you make another mapping to I, and then you go to P, and then you want to say, hey, you already have this. So this is the second case. You already have a mapping. That means that you could, if it's the same as T, then great, you're good to go. If it doesn't match the dictionary or both, then you want to return false. So let's kind of go about and do that. So we're going to create two sets here. So we're going to call this mapping. Oh wow, mapping is a keyword. Mapping from going from S to T. So let's see, S to T, and you want that to be an empty set. And you also want the mapping in reverse, so a mapping from T to S. So this is going to fulfill the requirement for isomorphic strings, because you have a character in S that maps to T, and then you also have a character in T that maps to S. So keep in mind that if G maps to D also on the T side has to map back to G, right? Because they have to go one-to-one with each other. So we're going to iterate through the characters in S and T. So we're going to iterate through the characters. So for character 1 and character 2 in, we're going to zip them together. Zip ST. What we're going to do is, so we're going to do our first case. So if we first iterate through the character, and we don't find, there's no mapping that exists, we got to make a mapping. So if the first character in is not in the mapping from S to T, and the character 2 is not in the mapping from T to S, then what we want to do is make the mapping, make it exist. So mapping from S to T is going to be assigned at C1 here. It's going to be assigned to C2, and mapping from T to S from C2 will be assigned to C1. All right, that's our first scenario, first case. Our second case is that else if so if we don't have a mapping, we make a mapping. If we already the second case is that either the mapping does not we see a character we've seen before and it doesn't exist in the second mapping. The second if we see a character in S that does not exist in T, then we know we have an issue, so return false. Or if we see a character in S that's not mapped to T, then we return false as well. So we need to know the mapping does not exist. It's not isomorphic, I should say. So the mapping from S to T, what we want to do is get the character C1, and it's not equal to C2. Or the mapping from T to S, get character 2, is not equal to the character 1. And if that's the case, you want to return false because it's not isomorphic mapping. Otherwise, return true for everything else. Alright, let's see if this makes sense. True. Alright, accepted. So we have time complexity being big O of n because we process through each character in both strings exactly one time. Since they're isomorphic, they're the same size length as well. So big O of n, where n is the length of S and T or T. And then space complexity is big O of constant space because each of the ASCII characters are fixed in a set, and that's and the characters in our dictionary are they're just kept at constant space. All right, that's it. Pretty nice one. The trick is to know the definition of isomorphic, and just kind of once you have the two dictionaries mapping type of algorithm or idea, the rest becomes pretty self-explanatory. And just developing the two cases here. Alright, that's pretty much it. Have a great day, guys.